All right, so this video is talking about everything we've kind of done so far with graphs and whether they're increasing, decreasing, their domain and range. We'll go back to positives and negatives today, as well as add this idea of relative maximums and relative minimums. So let's go on and get started with the intercepts. I'm going to quickly label them for us here. One's at -3, 0, 0, 4, and 2, 0. Those are x and y intercepts. All right, now let's deal with the increasing. Okay, so we're looking for the part where it's increasing. All right, so the graph is increasing right here at that section. And so we need to find out where it starts. And remember, whenever we talk about the intervals, whether it's increasing, decreasing, positive, negative, and the domain, we always use the x values or the domain numbers. We always look at the x numbers. Keep that in mind. So it starts at -3, and then it ends at 0. And now I know a lot of people would say, oh, it ends at 4, it ends at 4. Well, again, that's the y value. We want the x value, which is at 0 right there. So it increases from -3 to 0, and we can include both numbers. All right, and there's no other point where it increases, so now let's talk about the decrease. Okay, so it starts decreasing right here. I guess we'll talk about this section. All right, and notice this graph. This is one of those graphs where the graph actually doesn't continue in both directions forever and ever. Notice how it has a definite stopping point and starting point, and that's okay. It just makes our interval a little bit more defined as opposed to writing infinities. We can clearly see where it stops and where it ends. So it starts decreasing right here at -5, and it decreases all the way until -3. And then it makes a turning point. So we can include -5, we can include -3. All right, and then I see that it's decreasing in this large section right here. Now, don't be fooled by that intercept. So even though there's an x-intercept at 2, 0, it's decreasing that entire red line. So I don't need to say that it goes, so it starts at 0, and it goes all the way to 4. I don't need to say 0 to 2 and then 2 to 4, because it's decreasing that entire time. So all I need to write is that it starts at 0, and goes all the way to 4. I don't need it to go to 0 to 2, 2 to 4. Even though there's an intercept, we don't need to, if we're talking about increasing, decreasing. So it just goes down. All right, and we can include 0, and we can include 4. And of course, if I have 2 or more pieces, or 2 or more intervals, we write union, referring to there's 2 different parts that go together. All right, now let's talk about positive, negative, and the first thing I'll do with positive, negative is to draw a nice line on the x-axis, because it helps reminds me what parts are negative, what parts positive. So the positive is above the line, negatives are below the line. All right, so positive. So the graph is positive, so this first piece is right here. So it starts being positive, -5, and it stops at -3. Why does it stop at -3? Because when a point is on the x-axis, that means my y value is 0. And remember, if something is 0, it's not positive or negative, it's neutral. So I have to stop saying it's positive because it stops being positive at that point. So I can include 5, but I can't include -3 because it's 0, and 0 is not positive. All right, but it does pick up again, going this direction right here. It starts being positive above the line, starting at -3. And it does continue to be positive right here in this section. So it starts at -3 and goes all the way to 2. Again, I don't need to break it up, -3 to 0, 0 to 2, because it's all above the line. It's all positive. So I can continue to go from -3 to 2. I can't include -3, and because 2 is on the x-axis, I can't include that either. So they both get parentheses. So that's the positive part of the graph. And now let's go to the negative part, which is this section right here. Okay, so it's negative starting at 2. And then it goes all the way down to what appears to be 4. I can't include 2 because 2 is not positive or negative. But 4 I can include because it's not on the axis. So those are all my increasing, decreasing, positive, negatives. Now let's talk about the new part, relative minimums and maximums. Okay? And the best way I like to explain it is by drawing you a picture of a parabola. So let me draw one up here in the upper right corner. Okay? So parabolas, we love and know them. They're from our quadratic formulas and equations. So a key part of a parabola is its vertex. So here's the vertex. And I know that some of you probably remember this and like, why are we talking about this? Okay, this is a kind of a connection to your earlier days of algebra. Remember we said, is the vertex at the minimum or the maximum? Meaning, is the vertex at the lowest point of the graph or at the highest point of the graph? And in this picture, the vertex is at the lowest point of the graph, right? It's at the very, very bottom of the graph. So this is what we call a minimum. Or I'm just going to put min. And so an example of a maximum graph would be this. So the parabola is facing down, the vertex is up here. The vertex is at the maximum, meaning it's at the tallest point of the graph. So that's what we've done before. Here's the connection to what we're doing right now. So the question asks, are there relative minimums or maximums? Okay? Because there's more than one place where the graph turns, right? So here, on number 9, it turns right there, and right here. There's two places where the graph has like a turning point. It goes from increasing to decreasing or decreasing to increasing. So there's two different places where the graph has a minimum or maximum. So that's what we call relative because they're both they're minimums and maximums, but they're not the absolute minimum or maximum. So we call those relatives, the relative minimum or maximum. So right here at -3, 0, let's just take a look at just this part I've circled right here. So just that part of the graph. If we're looking just at that part, that point right here is a relative minimum. So that's a relative minimum because it's at the lowest point at that part of the graph. Okay? Then let's go ahead and put a dot right here because see how it switches from increasing to decreasing? So let's take a look at just at that part right there. At this point, this is the relative maximum because that is the tallest point on the graph or in that section of the graph, and that's a relative maximum. So on number 10, which I'll do in another video, I'm going to kind of go quicker through all these things, but that is how you find relative minimum and maximum. It's basically where the graph takes a turn, there's a curve, and like at that point, it's at a minimum point, meaning the lowest part of that graph, or the highest part of that graph, minimum or maximum. So there's kind of an explanation of everything we've done so far, as well as what we just learned today about relative minimums and maximums.